Mi nombre es Felipe Caselli, yo soy el director de la Escuela de Ingeniería Oceánica de la Universidad de Valparaíso, así que nuevamente les doy la más cordial bienvenida a todas, a todos. Y en esta oportunidad eh, estamos en este evento muy especial que se enmarca en el curso internacional sobre uso y modelación de datos históricos y proyecciones futuras bajo escenarios de cambio climático, que ya es la segunda edición. Esta instancia donde la ciencia y las soluciones aplicadas a las comunidades se entrelazan. Nuestra escuela de ingeniería oceánica tiene la convicción de que la ciencia y la ingeniería deben ser actores claves en la respuesta a los desafíos globales. Y por ello, promovemos no solo la generación de conocimiento de frontera, sino también su transferencia efectiva a los territorios, especialmente en aquellos expuestos a amenazas climáticas y oceanográficas. En este esfuerzo, la colaboración es un pilar fundamental. Hoy queremos destacar especialmente la articulación que ha hecho posible este curso gracias al compromiso de actores nacionales e internacionales. Y en este sentido queremos expresar nuestro profundo agradecimiento al proyecto de construcción de sociedades resilientes y sostenibles frente a desastres en Latinoamérica y el Caribe, llamado Kizuna 2, que es parte del esfuerzo conjunto entre el gobierno de Chile y el gobierno de Japón a través de sus agencias de cooperación, la Agencia Chilena de Cooperación Internacional para el Desarrollo, ACSID, y la Agencia de Cooperación Internacional del Japón, JICA, con la colaboración estratégica del Servicio Nacional de Prevención y Respuestas ante Desastres, SENAPRED, que forma parte activa de este programa. Este entorno colaborativo es el que nos permite contar hoy con 18 estudiantes provenientes de Bolivia, Colombia, Costa Rica, Ecuador, Honduras, Panamá, Perú, República Dominicana y Uruguay, así como la participación de un invitado verdaderamente excepcional. El doctor Hiroki Kondo es físico de formación por la Universidad de Tokio y cuenta con una trayectoria de más de 50 años en investigación, formación y liderazgo institucional en temas de meteorología, oceanografía y cambio climático. Ha ocupado cargos directivos en la Japan Meteorological Agency, ha sido director del Departamento de Investigación Climática del Instituto de Investigación Meteorológica de Japón y asesor del Ministerio de Educación, Cultura, Deporte, Ciencia y Tecnología del Japón ante las sesiones de la Conferencia del Cambio Climático para las Naciones Unidas y el IPCC. Fue también jefe de la Oficina Nacional del Apoyo al IPCC, el Grupo de Trabajo 1, en Japón, y ha tenido un rol destacado como científico principal en el proyecto japonés para el quinto informe del IPCC, desempeñándose en instituciones como el JAMSTEC y el RESTEC. Actualmente es asesor del Remote Sensing Technology Center of Japan, el RESTEC, y académico de la Universidad de la Ciudad de Yokohama, además de continuar colaborando activamente con JICA y el JMA en formación avanzada en cambio climático. En esta conferencia, el doctor Kondo compartirá con nosotros una perspectiva técnica y científica sobre la evolución del cambio climático global con base en la evidencia consolidada por el IPCC y otras agencias internacionales. Abordará también los escenarios proyectados por los modelos climáticos más recientes y las implicancias que estos tienen para la planificación estratégica, la cooperación internacional y el futuro de las zonas costeras vulnerables. Para nosotros es un honor contar con su presencia y su experiencia, ¿ya? Por lo tanto, a continuación le damos el pase al doctor Hiroki Kondo y les recuerdo nuevamente para quienes se están incorporando que hay un botón de interpretación donde pueden cambiar al canal en español si así lo desean, ¿ya? Doctor Kondo, por favor, puede compartir la pantalla y dar inicio a su exposición.
So let me start. So I'm going to talk under the title Analyzed and Projected Global Warming and Related International Policy Measures. So the contents of my talk consist of the following: introduction, origin of climate change issues and IPCC, First one, UNFCCC and Kyoto Protocol based upon IPCC. Second, Paris Agreement based upon IPCC. Third, current state of this climate, observed climate change. Fourth, drivers attributions of the climate change. Fifth, projection, possible future climate. Sixth, challenges to be addressed. And at the end, summary. And I'll make it open to your discussion in the last 10 minutes or so. Let me then proceed. Next slide, please. So introduction, origin of the climate change in tissues and the IPCC. Next. The climate as a system consists of various subsystems, including atmosphere, ocean, land, and so on. And they are affected by the activities of solar radiation and volcanic activity, and also by human activities. So it's a very complicated system. Next. Now, the most important factor of the activities is greenhouse effect. So the sun issues solar radiation towards the Earth. Most of the radiation was reflected by the clouds or the atmosphere and the surface of the Earth, but almost half of its radiation is absorbed by the Earth. On the other hand, the Earth is warmed by this radiation, and then the radiation itself issues Earth radiation, infrared radiation, and here you can see the radiated energy is part of it is coming back to the Earth, but part of it is going to the outer space, and however part of it is by the reaction to come back to the Earth. This is a very important part of the and it's called greenhouse gas. The greenhouse gas emit the radiation, part of its radiation towards the Earth surface, and this is a very essential part of the greenhouse gas effect shown here. Some of the infrared radiation passes through the atmosphere, but most is absorbed and re-emitted in all directions by greenhouse gas molecules and clouds. The effect of this is to warm the Earth's surface and the lower atmosphere. And this effect is called greenhouse gas. But without the greenhouse gas, however, the Earth will be without the living materials. Surface average temperature would be minus 19 degrees centigrade. So it's no more affordable for us to live on. So greenhouse gas is very important for the living matters on Earth. However, the problem is we are now losing the balance of these activities. Next, please. Now, let's see the composition of the atmosphere with starting from nitrogen, oxygen, argon, etc. And I'll show that in red inks, carbon dioxide, the fourth one. But nitrogen, oxygen, and argon consist 99.93% of total in volume rate. Carbon oxide 0.0391%, and so on. And methane, nitrous oxide, from ozone, etc. The red ink shows the greenhouse gases, and there is very tiny part of the atmosphere is showing is the source of the warming, which is called greenhouse effect. Next, please. Now, this shows changes of atmospheric concentration of carbon dioxide earlier years up to 2012, from starting years. The global observation of carbon dioxide started during the IGY, International Geophysical Year. It was from 1957 to 58. And then the purple line shows the smooth shown the value of South Pole observation. But the actual observation at the Mauna Loa, Hawaii, shows seasonal variations, but again, it is showing the rising, growing tendencies consistently. And recent Japanese Ryori observation is shown by green lines, and also this has a seasonal variation, but gradually increasing in the same rate. Now, it is now presumed by IPCC Fifth Survey Assessment Report AR5 that the value of the 1950, the concentration of carbon dioxide was 278 parts per million, ppm. But recent value, 2012, 393.1 ppm. It's plus 41%. I'll show you more later, part later, but we wonder what will happen if it continue to increase in the future. So that is the very important question at that time. Next slide, please. And the scientific origin of climate change issues comes from a question: what will happen if global scale concentration of carbon dioxide continues to get larger? So based upon model simulation study of the response of the climate to the increase of carbon dioxide concentration, Shukuro Manabe from Japan and his group at the GFDL, Geophysical Fluid Dynamics Laboratory in Princeton University, USA, predicted global warming already in the 1970s. So his research results affected the world scientists very much, and finally he was awarded Nobel Prize in Physics in 2021. Next slide, please. So the worldwide research activities then established IPCC, and IPCC is an intergovernmental panel on climate change, a United Nations body for assessing the science related to the climate change, established in 1988 under the cooperation of WMO and the UNEP. WMO is the World Climate Meteorological Organization, UNEP, United Nations Environment Program. IPCC issues assessment reports concerning the scientific aspects of the climate change, special reports, and others. Next, please. The IPCC consists of under the WMO and UNEP, we have a plenary, and we have 3 working groups. Working group 1 focused on physical science basis. Second one, impacts, adaptation, and vulnerability. Third working group on mitigation, and so on. Next slide, please. And recent assessment report is 6th assessment report. It was issued from 2021 to 2023. Working Group 1 was first issued its assessment report. The Working Group 1 focused on physical science basis. Okay, physical science basis. Working Group 2 focuses on impacts, adaptation, and vulnerability of climate change. And Working Group 3 on mitigation of climate change. So I'm going to talk mainly following the report, assessment report by Working Group 1. Of course, I'll also refer some other the part working group's report. Next, please. And then the IPCC is issued first assessment report, and it is a very good activity, and affected the policymakers worldwide. And eventually, UNFCCC and the Kyoto Protocol were based upon. So next slide, please. So far, we have 6 assessment reports in the past. I just show earlier reports and with main messages. First one was issued in 1990, and the main message is continued accumulation of anthropogenic greenhouse gases in the atmosphere would lead to the climate change. Anthropogenic means man-made, human originated. Okay, so and second assessment report in 1995, the balance of evidence suggests that there is a desirable human influence on global climate. But still, this assessment is not yet quite sure. They can show some possibilities, but it's not so certain. But third one is coming a little bit certain, and which was issued in 2001, saying most of the observed warming over the 50 years is likely to have been due to the increase in greenhouse gas concentrations. Likely in this report means probability of 66 to 90%. So to some extent, at the stage of third report, the IPCC is coming to more precise certainty. Next, please. I also mentioned the World Peace Prize 2007, which was awarded jointly to Intergovernmental Panel on Climate Change and at that time the Albert Arnold Gore Jr. from United States of America, and in this award, earnest activities of IPCC of assessing the most advanced scientific, technological, and socio-economic findings have been appreciated as the basis for decision making on climate change. So next, please. So in 1990, the United Nations are now concerned about the activities of IPCC. So following the first assessment report, which was issued in 1990, in December, the United Nations established a negotiating committee on a framework convention on climate change. And through various activities, in May 1992, 2 years later, UNFCCC, United Nations Framework Convention on Climate Change, this is the convention, was adopted by the United Nations. And here I would like to show the most important articles. Its articles. uh, that is Article 2, objective of UNFCCC. The objective, the ultimate objective, blah, 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 is to achieve, blah, 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 stabilization of greenhouse gas concentrations in the atmosphere in a level that would prevent dangerous and anthropogenic interference with the climate system. And then March 1994, UNFCCC, UNFCCC entered into force. Next, please. At the time discussion was made, there is the carbon dioxide emission rates among the Annex 1 countries in 1990 is shown like this. Here, the Annex 1 countries means the developed countries, because the developed countries had been emitting carbon dioxide through their industrialization. And so at this stage, they are responsible to the increase of the carbon dioxide. And so the Annex 1 countries are requested to show their effort to make some cut of the consumption of carbon dioxide. And I'm sorry, to diminish the carbon dioxide in their industrial activities. At this stage, USA emitted carbon dioxide 36.1% of the total emission. This is among the developed countries, but so this is very large amount. Second emitter is Russian Federation, third Japan, and so on. Next, please. So, under the UNFCCC, at the third session of UNFCCC, which is called COP3. COP3 means third session of Conference of Parties of UNFCCC. There necessity of reducing the uncertainty in the projection of climate change. So IPCC was requested to make more assessment, and science community are requested to make more certain findings. Second one, target qualified emission limitation and reduction in order to promote sustainable development was requested. And in COP3, it was decided to greenhouse gases to be reduced by Annex 1 countries, developed countries, carbon dioxide, methane, and so on, based on 1990 level, and others based on 1995 level, and so on. And target rates at least 5% reduction in total to be achieved by the Annex 1 countries in their commitment period 2008 to 2012. Japan -6%, USA -7%, EU -8%, Canada -6%, etc. And also emission sources and removal sinks from land use change and forestry activities uh, to be used to meet the commitments. Next, please. I'm not going into the details of Kyoto Protocol, but meanwhile, the IPCC continues to issue its assessment reports, particularly concerning Working Group 1. Fourth assessment report, for the first time, made a very clear messages. Warning of the climate system is unequivocal. Now, at this stage, IPCC assessed that the science shows the warming is really occurring, and it is unequivocal. Unequivocal means not ambiguous, plain, unmistakable. Very, very assertive word, but assertive language. Most of the observed increase in the global average temperature since the mid-20th century is very likely due to the increase in greenhouse gas concentration. Or this one is showing the cause of the global warming. It's called attribution. So the global warming is attributed to the increase in greenhouse gas concentrations. This is still
Ahora entonces,
very likely
es muy probable
second certain language in
que es la
IPCC,
segunda palabra más precisa en el IPCC que se
is
utiliza,
still not unequivocal, but
que sin embargo no es
very
tan
likely
categórica
is
como
a strong
inequívoco, pero es muy probable.
wording,
Sigue siendo una palabra bastante concreta,
showing more than
que muestra
90%
más de un
certainty.
90% de certidumbre.
And then 2013
Luego, el
and
2013,
2014,
2014,
AR5 Fifth Assessment Report
el informe AR5 muestra
showed that
que
it is extremely likely
es
that
extremadamente probable
influence has
que
been
la
the
influencia
dominant cause
humana ha
of the
sido la
observed
causa
warming since the
dominante del
mid-20th century.
calentamiento observado desde mediados
Extremely
del
likely
siglo XX. Extremadamente probable es la otra
has a
expresión,
probability of 95 to
que lleva una probabilidad
99%.
de un 95 a un
Extremely
100%.
likely
Extremadamente
is
probable.
stronger word
Es una palabra incluso más
than
fuerte
very likely, but still
que muy
not
probable,
so strong
pero
like
aún
unequivocal.
no es tan
Still
fuerte como
need
inequívoco.
time.
Aún se
And
necesitaba tiempo.
finally, at the
Finalmente,
stage of
en la
sixth
etapa
assessment report,
de la sexta reporte de
issued
evaluación que
2021
se
and
emitió el
2023,
2021 al 2023,
and working group one
el grupo de trabajo
contributions
1 y su
was issued in
contribución que se emitió el
2021.
2021
It says it is
dice,
unequivocal
es
that human influence has
inequívoco que la
warmed the
influencia humana
atmosphere,
ha
ocean, and
calentado la atmósfera, el
widespread
océano
and
y la
rapid
Tierra.
changes in the
Hay
atmosphere,
cambios
ocean,
esparcidos y
cryosphere,
rápidos
and
en la
biosphere
atmósfera,
have
océano,
altered.
criosfera que han
But
ocurrido.
here, for the first
Aquí,
time,
por
the
primera vez,
language
el lenguaje
unequivocal
es
was
inequívoco
used
que se
at the
utilizó
stage of sixth
en
assessment
la
report
etapa de la sexta,
in
sexto
2021.
información o reporte
So
del
the
2021.
science
Por lo tanto, la
shows
ciencia muestra
that
que
the cause of
la
the
causa
global warming at
del
this stage.
calentamiento global en esta
Next,
etapa
please.
es lo que damos acá. Próxima diapositiva, por favor.
On the other hand,
Por otra parte,
the global economic activity
la
is
actividad económica
changing,
global
and
ha ido cambiando, por supuesto.
it it was remarkable that
Y fue notable el hecho
once developing country,
que
China,
China
now using a lot of
estaba
carbon, carbon
emitiendo una
dioxide.
gran cantidad de dióxido de carbono.
And this is the 2021
Y
estimate.
esta es una estimación del 2021.
China consumes
China
and emit
consumía y emitía
fossil carbon dioxide
dióxido de
emissions
carbono de emisiones fósiles,
much more,
que era
more than
muy superior
double
y casi más que
USA.
duplicaba las emisiones de Estados Unidos.
So China,
Por lo tanto,
USA, India,
China, Estados
Russia,
Unidos,
Federation,
India,
Japan,
la Federación
and so on.
Rusa, Japón, en ese orden.
Next, please. Next, please. Now, the Kyoto Protocol has, in my view, two problems, issues. One is that the USA get out of the treaty, and second problem is that the now not only the developing countries like China is much more big consumers and emitters of carbon dioxide. Next, please. And so the COP in later part made a lot of discussions how to address these issues, problems, particularly in two problems. So through the discussion, long discussions, the UNFCCC finally decided that it is it's better to show by all countries, not only developed countries, but also developing countries, that what they can do for the purpose of UNFCCC's objectives to stabilize the carbon dioxide concentration in the atmosphere, and so. And so the UNFCCC through the many discussions come to agreement that we had better that each country should provide their efforts, their ambitions, and their effort, and all these efforts should be get together. So finally in Paris Climate Change Conference in 2015, COP21, 21st session of COP, adopted Decision 1, called Decision 1 CPT.121 on Paris Agreement. in which all UNFCCC parties are supposed to participate in, including United States of America. On 5th October 2016, the Paris agreement was entered into force. Sorry, on 5th October 1916, the threshold for entry into force of Paris Agreement was achieved. And then through the various procedures, the Paris Agreement entered into force on November 2016. Next, please. Here I'll show some of major elements of Paris Agreement. In Article 2, the agreement shows this agreement aims to strengthen the global response to the threat of climate change, including by holding the increase in the global average temperature to well below 2 degrees above pre-industrial levels and pursuing efforts to limit the temperature increase to 1.5 degrees centigrade above pre-industrial levels. So 2 degree and 1.5 degree major focal points. Parties, in Article 4, parties to reach global peaking of greenhouse gas emissions as soon as possible and to undertake rapid reduction thereafter in accordance with best available science so as to achieve a balance between the anthropogenic emissions by source and removals by sinks of greenhouse gases in the second half of this century. And so on. And the conference of parties serving as the meeting of the parties to this agreement shall consider common timeframes for nationally determined contributions at its first session. Now, also the very important part is the second one. Each party shall communicate a nationally determined contribution, NDC, every 5 years. So every party is requested to show their ambition or efforts every 5 years. Next slide, please. At the stage of the 2015 nationally determined contributions, NDCs, by major countries are shown as follows. I'm not going into details in all these, but EU, USA, Japan, China, Brazil, and so on. For example, EU at least 40% compared to 1990 level by 2030. So that's their ambition or effort target, reduction target, and so on. However, next slide, please. If you all these pledges are satisfied, what will happen? So there is a assessment that based upon nationally pledges and MDCs at the stage of 2015, there was a research that based upon their MDCs, temperature change projected and at the stage of 2100, the temperature increase would be above the pre-industrial level, plus 2.5 to plus 2.85 degrees. So if they keep their promise, we cannot attain the UNFCCC's target plus 2.0 degree target, much less 1.5 degree target. So next slide, please. On the other hand, IPCC continued to work, and at the stage of AR6, it was shown that it is unequivocal. For the first time, the language unequivocal is used here for the assessment of influence, that human influence has warmed the atmosphere, ocean, land. This is for the first time, the cause is human influence, not natural changes, but the human influence has caused the global warming. So they assess that is the unequivocal. Widespread and rapid changes in the atmosphere, ocean, cryosphere, and biosphere has occurred. So next slide, please. Now, in a long years, the reconstructed and observed global mean temperature, global mean surface temperature, relative to the 1860 to 1900 mean. This is average value of this period is assumed approximately pre-industrial temperatures. Normally, pre-industrial temperatures is the temperature in 1750 and 1750. But at that time, the observation data is not enough, or not enough. So normally we assume instead average value of this 1850 to 1900 average at the pre-industrial level. And at the recent value, there the changes are now 1.06 degree higher in 2011 to 2020, latest 10 years mean. So let's see the more precisely the situation between 1850 to 2020. Next slide, please. So this is 1850 to 1900. The average of this temperature is the basis, okay? And the former slide shows the up to 2020, according to the AR6. But the most recent observed values have been announced by WMO. And the WMO issued the report that the global average surface temperature in 2024, last year, was 1.55 degrees centigrade above the 1850 to 900 average, normally the pre-industrial level. And according to WMO's consolidated analysis of the six database sets. So this was issued by WMO 10th January this year, 2025. And you see that this level, 1 degree above pre-industrial level here, and 1.5 degree above pre-industrial level here. And last year's global average temperature is more than them. The global average surface temperature in 2024 was 1.55 plus minus 0.13 degrees centigrade above the pre-industrial average and the highest on record. Okay. Next slide, please. Now, on the other hand, the observed change in surface temperature in the past 110 years was shown by AR5, the former report. But this is very important, that interesting that the temperature increase, global warming is more severe on land compared to on ocean. So land area is more larger. Land areas have larger increase than those on oceans. Next slide, please. Now let me see. Let me show you that there are several phenomena concerning Arctic sea ice extent. The other side for you, the Arctic areas, but Arctic sea ice extent is a very important factor to show that the climate change. The very large observations are made, and here in September, the amount Arctic sea ice extent area, the width area of ocean with more than 15% sea ice. So it goes sea ice extent. Sea ice extent is lowest value has every year has lowest value in September, here, September. And the lowest one was happened in 2012. And last year, it was like this. And most of the data shows most of the year, many observations are coming to this. Well, let me show you next slide more precisely that in September value. Next slide, please. Yes, average monthly Arctic sea ice extent in September from the so the value is with some variations, but going down lower part, and this is clearly show the downward trend. So next slide, please. This is very clear. And next, I'll show you what is happening in ocean. Ocean warming dominates the increase in every energy stored in the climate system, accounting for more than 90% of energy accumulated between 1971 and 2010. So ocean contains most of the global warming energy, contained. Recent one up to 2010, ocean, upper ocean and deep ocean. Ocean shows more than 90% of the energy. Okay, and ice consumes consumed energy here, melting them. This part, land here, and atmosphere, very tiny purple part. It's only a few percent. Most of the energy is contained in the ocean. This is very important message. Next slide, please. And the next is concerning sea level change. It's also is showing a very consistent and growing, consistent growing. So, okay, next slide, please. Now, let's see the factors to cause recent sea level rise by AR5. It is very likely that the mean rate of global average sea level rise was 3.22 millimeter per year between 1993 and 2001 with high confidence. And so this is a observed amount of sea level rise, 3.2 millimeter per year, okay? 3.2. But some of the observed contributions are now found. Larger one is the thermal expansion of the ocean, 1.1. Glaciers melting, 0.76. Greenland ice sheet melting, 0.33. Antarctic ice sheet melting, 0.27. And land water storage, 0.338. And total of these causes are now summed up 2.8 millimeter per year. So out of 3.2 observed value, 2.8 can be attributed, are now attributed. So it's a very it's not exact one, but we show that to some extent we are now attributing the causes of the melting, rising of the sea level. Rising of sea level is now attributed. Next slide, please. And also, this is a you may feel recent years that extreme weather and climate events are now quite clearly shown by AR6. Human-induced climate change is already affecting many weather and climate extremes in every region across the globe, including your regions also, I presume, in Japan also. Evidence of observed changes in extremes such as heat waves, heavy precipitation, droughts, and tropical cyclones, and in particular, their attribution to human influence has strengthened since AR5. So we are now very much affected by these events. In Japan, we have very much suffered a high temperature summer last year and this year also, much more higher than last year. Some recent hot extremes observed over the past decade would have been extremely unlikely to occur without human influence on the climate system. So, next slide, please. Drivers and attribution of climate change. Next, please. So what is the cause? Main drivers, main external forces of climate change. On the one hand, there are natural drivers to cause change, like volcanic eruption, solar activities, etc. But these are always occurring for them. But on the other hand, anthropogenic drivers is growing greater than before, increasing after 1750 because of the Industrial Revolution. Emission of greenhouse gas, this caused through greenhouse gas effect. Emission of aerosols. Aerosols is a small particle suspended in air. These are both having a cooling effect and in some case warming effect, but totally aerosols effect is affecting a cooling effect. But the greenhouse gas effect is greater than that. There are also land use change of albedo. It's not so large, but the albedo change causing some cooling. But this is very small part. And so the emission of greenhouse gas is the main cause of greenhouse effect, through greenhouse effect to cause climate change. Next slide, please. The composition of atmosphere is most of them are 19 nitrogen, oxygen, argon consists of 99.93%, but carbon dioxide 0.0391%, and etc. And red one are warming effect, have warming effect. But these are very, very tiny part compared to these main compositions, nitrogen, oxygen, argon. Next slide, please. The change of the carbon, three major greenhouse gases, carbon dioxide. Okay, this is from this is the Western calendar. 0, 1000, 1750, and 1000, 2000 coming this way in this scale, but it's so small part, so it's along up to here. So 2000 here, not here, but 2000 here. So this is the recent very precise change. Okay. After 1750, revolutionary industrial revolution around here. Okay, but large increase occurred the industrial revolution after industrial revolution. So now carbon dioxide is plus 40%, methane 150%, nitrogen dioxide, nitrous oxide is 20% plus 20%. Next slide, please. The most recent global atmospheric concentration of carbon dioxide is shown here. Again, the South Pole value with the this is the global atmospheric concentration. So this is there is a global average of CO2 concentration. So there is a seasonal changes. Okay, with the seasonal changes, and if you smooth out the seasonal changes, it shows the very gradual, very consistent rising. And the value of carbon dioxide concentration in 1750, before the industrial revolution, 278 ppm. Now the recent one, 2022, it takes a little bit time to be available. So this is available recent one, 417.9 parts per million. It's 50% larger than the pre-industrial value. Okay. Next slide, please. And balance of sources of sinks with carbon dioxide. The carbon dioxide okay, the fossil fuel cement amount, this part. Land use change from data and models. Land use change, this part. On the other hand, ocean sinks here, and measured atmospheric growth rate. This is measured atmospheric growth rate, atmosphere, okay? Atmospheric carbon dioxide. The computed part is here. Residual land sink. So land sink is it's very difficult to take observation data, but it's now presumed by other data that this is consumed residual land sink, the residual land sink amount here. Okay. Now, next slide, please. The annual global fossil carbon dioxide emission is growing larger. However, recently there was the COVID-19 pandemic caused some downward changes here. But again, next year, this is up to 22 was projected value, but this is large coming back values. This is an annual global total fossil fuel, okay, global. Next slide, please. So the annual fossil fuel emissions by countries, China is now by large amount here, but here it's a small decrease by COVID-19 pandemic, by the pandemic. The USA is now not the largest emission country, but second. And total EU amount here. And India, the value is growing larger gradually. But by far, China is the largest emitter. And this is the other part, the other countries. Others. Next slide, please. So we have now various observed data in the past many years, up to, for example, 1850. Up to 1850 to now, we have a lot of observed data, and the temperature, global mean temperatures is now calculated by all these data. So the thick black line shows observed temperatures from 1850. Okay, this way and this way and this way, and this is, and there is some and this way and black. This is observed value. Okay, you see various volcanic eruptions affected temperatures going down a little bit, going down a little bit. But now we have the the coupled model intercomparison project have been taken place, and now we have 60 models result here, including Japan's 3 models here. 60 models. So they tried to simulate the last years from here. They put the observed the data and also the volcanic eruption data, and each of the resulted value is shown here. The simulation of the past climate. The average of all these 60 model results is shown by red thick line here. You see that this is quite much show the essential tendencies of black line. So that is a very important part of today's talk, that now model simulation is now we have now 60 model results, and so the very clear and very consistent result. Next slide, please. Based upon this very useful 60 models, if they do not include the anthropogenic effects, then the result shows in a blue line. This one. Oh, there is no observed result, but this is simulated results in this way. There is no global warming, no big warmings. But if we include all the observed carbon dioxide changes, increases, then, as we already seen, the black line and these line consist very much along the line that the data shows. And all the data is shown by here. Simulated results, okay? Simulated human and natural with human and natural drivers. This is without human influences. Okay, so the temperature would be this way if there was no human influences. That is why, because of this, a large number of model results, for the first time, IPCC assessed that it is unequivocal that human influence has formed the ionosphere, ocean, and land. Unequivocal. Next slide, please. So using these models, we can more confidently use the result of various experiments. Next slide, please. AR5 was the one latest, but the latest one, AR6. In AR5, there was four scenarios observed, proposed. Okay, social, economic scenarios. The actual observed value of the carbon dioxide emission is this way, emission amount. And that is almost the highest scenarios, highest emission scenarios, lowest emission scenarios. Okay, four scenarios, and this is the emission amount, okay, emission amount. And the lowest scenarios, along the lowest scenarios, the average temperature increase is plus 1.6 degree from pre-industrial levels. This is pre-industrial levels, and this is already at some value, and then we come this way. However, still it's not, it's above 1.5 degree Paris Agreement target, and this one still more than 2 degrees. Still again, it fails to meet the Paris 2 degree target. And so then in this AR6, next slide, please. In AR6, they tried to apply better scenarios. So the lowest scenario here shows the emission is going down, and zero and minus this way. Take out of the atmosphere carbon dioxide atmosphere and put the carbon dioxide into the ocean or into the earth or so. That's the only way to come close and 0 point here. Okay. And this one, how the result. And this one next to low scenario is this way. So here again, here the 0.00 emission point here. Okay. Okay, next slide, please. So this is the temperature change along the each scenarios. Lowest, very low scenario, in this case, it goes up 1.5 to some extent, but then come back to 1.5 again, and eventually in the end of this century, it will be below 1.5 degree. This satisfies Paris Agreement. And second lowest scenarios, it satisfies 2 degree target. And okay, well, they are medium, high, very high scenarios. And all scenarios, global warming will very likely exceed 1.5 in this case also, but in this case, again, it come back and low and cyber. However, under the very low scenarios, after temporarily exceeding 1.5 degree, it will be coming down less than 1.5 degrees. So next slide. So here are the results in digital values, and very low. It estimate these years, okay, 1.5, 1.6 to these years, and at the right, at the later part of this century, 1.4 again. Okay, this satisfies Paris Agreement. Very high, on the other hand, very high scenarios, 4.4. In the end, 4.4, 4 degree, more than 4 degree. Next slide, please. And now we're talking about the degree, various case of temperature increase. Here, the distribution of temperature increase, global distribution of temperature increase. In the case of 1.5 degree increase, this way, the northern part is larger, okay? 2 degree increase, also it's more, so 4 point on this way, okay? And in any case, the land is more hotter than on land. The air is more hotter than on the ocean, okay? That is. And managed climate systems became larger and in direct relation to increasing global warming. They include increases in the frequency and intensity of hot extremes, marine heat waves, heavy precipitation, and in some regions, agricultural ecological droughts, and increase in the population of intense tropical cyclones, and so on. Next, please. Precipitation change. Well, precipitation also projected 1.5 global warming, 2 degree global warming, 4 degree global warming, 3 cases. The dry areas became more drier. Dry area became much drier, and wet area became much wetter. So anything, so precipitation is quite intense in many ways. Dry area is going to be more drier. Wet area is more wetter along with the global warming. Next slide, please. So sea ice, well, I'll just show you one thing, that in the future, along with various AR6, the lowest and highest scenarios, in three scenarios, the Arctic sea ice will diminish. practically ice-free values is here. So in three cases, there will be no Arctic sea ice in the future, in the later part of this century. Okay, next slide, please. Oh, well, sea level change in this way. It's a little bit precise matter, so I just skip this slide. Next slide, please. So next one is also a very important one. Cumulative total emission of carbon dioxide and global mean surface temperature response are approximately linearly related. This is already pointed out in AR4, but it is very important even now. So next slide, please. Now, these are the changes. These are the carbon dioxide amount, accumulated carbon dioxide amount, okay, this way. And this way is the temperature changes, okay, compared to the pre-industrial. Okay. These are the observed changes as the cumulative carbon dioxide increases, temperature increases this way. And in 2000 and at the 2019 value is here. The accumulated carbon dioxide is 2090 gigaton here. Okay. And the projection is started from here. The lowest scenario is coming to this increase. Accumulated amount is growing this way, and from here, and largest and highest scenarios, in case of the highest scenarios, it took the cumulative carbon dioxide comes this way. This one is, and the temperature is around here. There are some uncertainties here, but this one, and lowest scenarios here, and uncertainties here, and around here. So 1.5 degree increase is here. This is temperature increase. So in 1.5 degrees is coming here, and this one coming this way. It shows when the accumulated carbon dioxide emissions come to this value, then the temperature will increase 1.5 degree in any scenarios. This scenario here. So to keep warming within 1.5 degrees, acceptable amount of emissions are this amount, about 500. So so this is called budget for 1.5 degree target, 1.5 degree target budget. So this is the budget, 1.5 degree budget. Only we have 1.5 degree, this amount of acceptable amount. Next slide, please. Next slide, please. So the problem, the problem under the Paris Agreement to address 1.5 degree target in conjunction with the Paris Agreement, COP21 invited IPCC to prepare an IPCC special report on global warming 1.5 degree. Latest ratification status agreement, 195 parties out of 198 parties to the convention are parties to the Paris Agreement. However, as you may know, that on November, USA notified withdrawal, but 20 January 2021, USA come back to Paris Agreement, but this year, the newly elected president of USA announced withdrawal from the agreement. So USA is quite changeable in these days. However, the global treaty is very much accepted almost all the countries. Okay, next slide, please. The IPCC was requested to make a report on global warming 1.5 degrees because the policymakers is eager to know the science concerning 1.5 degrees. So IPCC was issued the report with a very complete title, with a detailed title, long title. IPCC special report on the impacts of global warming 1.5 degree above pre-industrial levels and related global greenhouse gas emission pathways in the context of strengthening the global response to the threat of climate change, sustainable development, and efforts to eradicate poverty. As shown above, the report also responds to the United Nations ongoing Sustainable Development Goals, SDGs. The report was completed in September 2018, earlier than AR6, focusing on 1.5 issues. Of course, AR4 itself talking about 1.5 degrees, but now policymakers wanted to know much more precisely on focusing on 1.5 degrees. And policymakers, including those from regions vulnerable to the impact of global warming, such as global sea level rise, are increasingly concerned about 1.5 degrees. The small island countries are by far the most concerned about that. Next slide, please. Emission pathways and system, and this is so emission pathways and system transition to attain 1.5 degree targets. In model pathways with no or limited overshoot of 1.5 degrees, global net anthropogenic carbon dioxide emissions decline by about 45% relative 2010 levels by 2030. This is the target, and reaching net zero amount around 2050. These are necessary, okay, to attain 1.5 degree target. Global carbon dioxide emission amount need to be reduced to half around 2030 and zero around 2050. So it shows the existing national determined contributions are not enough. Next slide, please. So the existing reduction targets by various countries, these countries are saying 2030 targets in this way, not consistent, but they also zero by 2050. This is consistent to all the countries. Of course, now under the Paris Agreement, not only developing countries are also showing their willingness to make some reduction. China, India is a little bit complicated, but but so far the developed countries showing the carbon neutral, zero emissions by 2050. Next slide, please. So this is a summary of today's my talk. Summary, but it is very important. So I read again. I read this one because it's very important. IPCC working plan AR6 was published in 2021 as a physical science assessment. Warming of the climate system is unequivocal since AR5. This is already made clear in AR5. Evidence of observed changes in extremes such as heat waves, heavy precipitation, droughts, and tropical cyclones, and in particular, their attribution to human influence has strengthened since AR5. According to model experiments, it is unequivocal, again, unequivocal, that we have now two unequivocals. This is the observed fact. This is the studied fact, accumulated. This is unequivocal, and human influence has warmed the atmosphere, ocean, and the land. This is newly shown in AR6. Under the scenarios of AR6, global warming will very likely exceed 1.5 degrees within 20 years. However, under the very low scenario, after temporarily overshooting 1.5 degrees, it will become coming down less than 1.5 degrees. Many changes in the climate system became larger in direct relation to increasing global warming. They include increases in the frequency and intensity of such extreme events as hot extremes, marine heavy heat waves, heavy precipitation, and so on. Cumulative emissions of carbon dioxide largely determine the global mean surface temperature by the late 21st century and beyond. Budget for the 1.5 degree target acceptable amount is about 500 degree carbon dioxide at 2019. The existing NDCs under the Paris Agreement may not be enough. The only slight hope is existing in the Article 4 of the agreement. They are the parties are the parties of the agreement are requested to show their new contributions. Okay, that's the whole of my summary. So I think I stop talking here, and I'll accept any questions by the audience. Thank you.
Muchas gracias, Kondo Sensei. Muy interesante la presentación, como siempre, y tenemos ya tres preguntas aquí en la sección de preguntas y respuestas. Aprovecho de recordarle a la audiencia que todavía pueden dejar ahí sus preguntas. Tenemos ahí 10 minutos como para resolverlas. La primera de ellas es de don Jesús Sánchez. ¿Cuál de los tres grupos de trabajo del IPCC enfrenta más retos para comunicar sus hallazgos a la sociedad y tomadores de decisiones?
Well, of course, all three working groups are related to that question, but mainly third working group, working group three, is concerned about the mitigation, and that is related to the policy making of how to control the warming. That's my view.
Muchas gracias. Segunda pregunta de don Guillermo Enrique Pepe. En la diapositiva de emisiones anuales de CO2, se ve que tiene un ascenso sostenido, salvo tres caídas. Una en el 2020 asociada al COVID y otras dos en 1990 y en 2009 aproximadamente. ¿A qué se debieron esos otros dos descensos puntuales?
Well, according to the graph showed you, there are some still need time to see the observed value because the latest one is still the projected value. So I'm not quite sure. I'm not. I just refrain from saying any presumable comment.
No. No, me imagino que es sobre esta diapositiva que está haciendo la consulta.
Yes.
Claro. Entonces, pasamos a la siguiente. La tercera pregunta es... espera un segundo que ahí sí. De don Juan Salazar, que dice, en el contexto del incremento de la temperatura oceánica, ¿existe la posibilidad de que la
Yes.
circulación termoalina se detenga en algún momento?
You mean the ocean circulation?
Es claro, respecto del incremento en la temperatura oceánica, efectivamente.
Well, well, yes, yeah. In the very long time range, the if the global warming continues, then at some stage the global ocean circulation cycle, circulation current may be reversed. Its way, particularly on northern Atlantic, and so now the warm current is going up to the North Sea in the Atlantic, but this current may lose the speed. And in the end, there would be some irreversible moment, turning point over which the current may stop at the northern part of the Atlantic,
Mm.
and which may cause some cooling effect in the upper part of Atlantic, affecting Europe area. Right now, because of the warm current, the Europe is warmer than other part of the northern areas like the Siberia or and some other Canadian and areas, and but that is one point that can be happened. Yeah, so far there were very few studies on that, but so we are not quite sure. But so the IPCC has not yet assessed in this point in any report yet.
Muchas gracias, Kondo Sensei. Aquí con eso llegamos al final de las preguntas. Yo sé, me imagino que hay muchas más preguntas que surgen. A mí se me ocurren varias, pero coincidentemente también estamos llegando al final del tiempo que teníamos para esto. Quiero nuevamente darle las gracias para allá está en Japón, así que él está muy temprano en la mañana, nosotros acá en Chile estamos muy tarde ya en la noche y el resto de nuestros amigos aquí latinoamericanos están en distintos horarios, pero todos ya tarde. Así que nuevamente muchas gracias a Doctor Kondo, a toda la audiencia por su
Thank you.
participación. El video este va a quedar disponible en el canal de YouTube de la Escuela de Ingeniería Oceánica y vamos a compartirles también la presentación a todos los que asistieron. ¿Ya? Así que, y a quienes ya participan del curso de herramientas para el cambio climático, nos veremos mañana en la primera sesión de clase ya formal. ¿Ya? A todos muchas gracias, que tengan muy buenas tardes, buenas noches y buen día para quienes nos acompañan desde Japón. Que estén todos muy bien. Muchas gracias.
You. Bye.